Bismillahirrahmanirrahim. Bismillahirrahmanirrahim. Structure of molecules. Introduction. The things around us are composed of matter. All matter is made up of the building unit atoms. These atoms combine to form molecules which appear in different states of matter around us. The forces responsible for binding the atoms together in a molecule are called chemical forces or chemical bonds. The bonding forces which keep the atom together will be discussed in this chapter. Why do atoms form chemical bonds? It is a universal rule that everything in this world tends to move from stable atoms, achieve stability by attaining electronic configuration of noble gases. Helium, neon, or argon, etc. In Ns2, Np6 having 2 or 8 electrons in the valence shell is single stability. Attaining 2 electrons in the valence shell is called a Planar role, while attaining 8 electrons in the valence shell is called a Planar role. The noble gases do have 2 or 8 electrons in their valence shell. It means all the noble gases have their valence shells completely filled. Their atoms do not have vacant space in their valence shell to accommodate extra electrons. Therefore, noble gases do not gain loss or share electrons. That is why they are non-reactive. The importance of the noble gas electronic configuration lies in the fact that all other atoms try their best to have the noble gas electronic configuration. For this purpose, atoms combine with one another, which is called chemical bonding. In their words, atoms form chemical bonds to achieve stability by acquiring intergas electron configuration. An atom can accommodate 8 electrons in its valence shell in three ways: by giving valence shell electrons if they are less than 3 to other atoms, by gaining electrons from other atoms if the valence shell has 5 or more electrons in it, by sharing valence electrons with other atoms. It means every atom has a natural tendency to have 2 or 8 electrons in its valence shell. The atoms having less than 2 or 8 electrons in their valence shells are unstable. Now the question arises that how we identify the way an atom reacts. The position of an atom in the periodic table indicates its group number. As we have studied in chapter 3, the group number is assigned on the basis of valence shell. For example, group 1 has only 1 electron in its valence shell, and say group 17 and has 7 electrons in its valence shell. Mode of reaction of an atom depend upon its number of valence shell electron. It is discussed in next section. Chemical bond. A chemical bond is defined as a force of attraction between atoms that hold them together in a substance. In other words, during bond formation, there is some force which holds the atoms which hold the atoms together. The attaining at electron configuration in the outermost shell, either by sharing, by losing, or by gaining electron, is called octet rule. This octet rule only implies that noble gas electronic configuration should be attained by atoms when they combine or react. For example, like hydrogen or helium, which have only as subshell. This become the plate role. It plays a significant role in understand the formation of chemical bond between atoms. If the bond formation is between ions, it is due to an electrolytic force of attraction between them. But if bond formation is between similar atoms or between the atoms that have comparable electronegativities, then the chemical bond formation by sharing of electrons. This sharing of electrons may be mutual or one-sided. When two approaching atoms come closer, the attractive as well as repulsive forces become operative. The formation of a chemical bond is the result of net attractive forces which dominate the energy of that system is lowered and molecules is formed. Otherwise, if repulsive forces become dominant, no chemical bond will be formed in that case. There will be increase in the energy of the system due to creation of repulsive forces. Types of chemical bond. The valence electron which are involved in chemical bonding are termed as bonding electron. They usually reside in the incomplete or partially filled outermost shell of an atom, depending upon the way how these valence electrons are involved in bonding. They result in following four types of chemical bonds: ionic bond, covalent bond, dative covalent, or the coordinated covalent bond, metallic bond. Ionic bond: the elements of group 1 and group 2, being metals, have the tendency to lose their valence electron from forming positively charged ions. Words non-metal of group 15 to group 17 have the tendency to gain or accept electron. They are electronegative elements with high electron affinities. If atoms belonging to these two different groups, metals and non-metals, are allowed to attract, chemical bond is formed. This type of chemical bond, which is formed due to complete transfer of electron from one atom to another atom, is called ionic bond. The formation of NaCl is a good example of this type of bond. Sodium chloride is a simple compound formed by sodium that equal 11 and chlorine is that is equal 17 atoms. The ground state electronic configuration of these elements is shown below. The farmers indicated electrons in the valence shells of these elements. Sodium has only one electron and chlorine has seven electrons. Sodium, being electropositive element, has a tendency to lose electron, and chlorine, being an electronegative element, has a tendency to gain electron. Therefore, they form positive and negative ions by losing and gaining electron respectively. They attain electronic configuration to the nearest noble gases. By losing one electron from the outermost shell, sodium becomes Na and it is left with the 8 electrons in the second shell, which will now become the valence shell. By gaining one electron, chlorine atom and now also has 8 electron in its outermost shell and becomes Cl. And both of these atoms are now changed into positively charged ions. They stabilize themselves by combining with each other due to electrostatic force of attraction between them, such as. It is to be noted that only valence shell electrons take part in this type of bonding, while other electrons are not involved in such type of reaction. Heart is usually given out. The compound formed due to this type of bonding are called ionic bond, covalent bond. The element of group 13 to group 17, while when allowed to react with each other, they form a chemical bond by mutual sharing of their valence shell electron. This type of bond, which is formed due to mutual sharing of electron, is called a covalent bond. The energy change during the covalent bond formation and are of considerable value. When two atoms approach each other, attractive forces develop between electrons of one atom and nucleus of the other atom. Simultaneously, repulsive forces between electrons of the atom of two atoms as well as between their nuclei are also created when the attractive forces dominate due to decrease in distance between those two atoms. A chemical bond is formed between them. The formation of hydrogen, chlorine, nitrogen, and oxygen gases are few examples of this type of bonding. Types of covalent bond are described above. The covalent bond is formed by mutual sharing of electron between two atoms. The electrons that pair up to form a chemical bond are called bond pair electrons. Depending upon the number of bond pair, covalent bond is classified into following three types. Single covalent bond: when one electron is contributed by each bonded atom, one bond pair is formed and it forms a single covalent bond while drawing the structure of molecules. The structure of such molecules, the single bond pair is indicated by a line between those two atoms. A few examples of of molecules with single covalent bond are hydrogen H2, chlorine Cl2, hydrochlorine acid HO, and methane CH4. Double double covalent bonds when each bonded atom contributes two electrons to bond pair are shared and a double covalent bond is formed. These bond pairs are indicated as double the line between in those atoms in the structure of such molecules. The molecules like oxygen, auto gas, and ethene C2H4 show such type of double covalent bond, triple covalent bond when each bonded atom contributes three electron, three bond pairs are involved. Bond formation. This type is called triple covalent bond. Three small lines and are used to indicate these three pairs of electrons between those atoms in the molecules of such compound. The example of molecules having triple covalent bonds are nitrogen N2 and ethene C2H2. By this mutual sharing of valence electron, each of the contributing atoms attain but the octet or nearest noble gas electronic configuration. Active covalent or coordinate covalent bond or dative covalent bond. Then bonding is a type of covalent bond in which the bond pair of electron is donated by one bonded atom only. The atom which donates the electron pair is called donor and the atom which accepts the electron pair is called acceptor. A small arrow is usually used to indicate the atom and pair of electron been donated. The head of arrow is toward the acceptor atom. The non-bonded electron pair available on an atom like the N1 available on nitrogen is ammonia and H3 is called a non-pair. When a proton H approaches a molecule with a lone pair of electrons, that lone pair is donated to H and a coordinated covalent bond is formed. For example, formation of ammonium radical in the formation of BF3 boron in the formation of BF3 boron trifluoride molecules, the three valence three valence electron of boron atom pair up with three electron, one atom from each three fluorine atom. The boron atom, even after the sharing of electron, covalent bond formation remains short or defect of two electron in its outermost shell. Now, if a molecule with the lone pair approaches like this molecule, it accepts lone pair from that order and forms a coordinate covalent bond. The lone pair on nitrogen of ammonia molecules makes it is a good donor molecules to form a coordinate covalent bond as shown in figure. Polar and non-polar covalent bond. If a covalent bond is formed between two similar atoms, homoatoms and homoatoms, and shared pair of elec- shared pair of electrons is attracted by both the atoms equally, such type of bond is called non-polar covalent bond. These bonds are formed by equal sharing of electron pair between the two bonding atoms. This type of bond is called a pure covalent bond. For example, bond formation is H2 and Cl2, hydrogen to chlorine. If the covalent bond if the covalent bond is formed between two different types of atoms, heteroatoms, then the bond pair of electrons will not be attracted equally by the bonded atoms. One of the atoms will attract the bond pair of electrons with mm, more strongly than the other one. This atom element will be called as more electronegative. When there is difference of electron activity between two covalent bonded atoms, there will be unequal attraction of for the bond pair. There will be unequal attraction for the bond pair of electron between such atoms. It will result in the formation of polar covalent bond. The difference between electron activities of hydrogen and chlorine is 1.0, as the electron activity of chlorine is more, it attracts the shared pair of electrons towards itself with a greater force. A, a partial negative charge is therefore created on chlorine and internal partial positive charge on the hydrogen, and due to electron activity difference it creates polarity in the bond and it's called polar covalent bond. The delta sign indicated partial positive or partial negative charge that is developed due to unequal sharing of shared pair of bonded pair of electrons. The compound resulting from polar covalent bond are called polar compound. For example, water, hydrogen chloride, and hydrogen chloride. By using electron activity values, it's possible to predict whether a chemical bond will be ionic or covalent in nature. A bond formed between element of high electron active high halogen group and element of low electron activity alkane metals are ionic in nature. Incomplete There is complete transfer of electron between them. The bond between elements of comparable electron activities will be covalent in nature, as the bond between carbon and hydrogen in methane or nitrogen and hydrogen in ammonia. If the difference of electron activities between two electrons is more than 1.7, the bond between them will be predominantly ionic bond, and if it is less than 1.7, the bond between two atoms will be predominantly covalent. Metallic bond. The metallic bond is defined between as a bond formed between metal atom positively charged and due to mobile two or free electrons. The different properties shown by metals such as high melting and boiling point, good condition of heat and electricity, hard and heavy nature, suggest existence of different type of chemical bond between atoms of metals. In case of metal, the hold of nucleus over the outermost electron in weak because of large size atoms and greater number of shells in between nucleus and valence electron. Furthermore, because of low ionization potential, metals have the tendency to lose their outermost electrons easily. Resultantly, they lose or free electrons of all metals. Atoms move freely in the space between atoms of a metal. None of these electrons is attached to any particular atom. Either they belong to a common pole or belong to all the atoms of that metal. Nuclei of metal atoms appear submerged in sea of these very mobile electrons. These mobile electrons are responsible for holding the atoms of metals together, forming a metallic bond. A simple metallic bond is shown in figure 4.2. Intermolecular forces are discussed earlier. The forces that hold atoms in a compound are chemical bonds. In addition to these strong bonding forces, relatively weak forces are also exist in between the molecules, which are called intermolecular forces. The bonding and intermolecular forces of hydro, hydrochloric and hydrochloric acid are shown below. In it requires about 17 kg energy to break these intermolecular forces between 1 mole of liquid hydrogen chloride molecule to convert it into gas worth about 413 kg energy required to break the chemical bond between hydrogen and chlorine atoms in one atom of mole of hydrogen chloride. Dipole and dipole attraction and intermolecular forces, which are collectively called van der Waals forces, are electrical in nature. They result from the attraction of opposite charges, which may be temporary or permanent. The unequal sharing of electrons between two different property terms of atoms make one of molecules silently positive and other and silently negatively charged. As shared pair of electron is drawn towards and more electron active atom, it is a negatively charged as chlorine in hydrogen chloride. The other end automatically convertedly positively charged when partial positive and partial negative charge exist at different positions in our molecule. The adjust molecules will arrange themselves in such a way that negative end of that molecule comes near to positive end of other molecules that result in a net of forces attraction between positively charged ends of two adjacent molecules. These attractive forces are called dipole and dipole interaction are represented in HCl. Hydrogen bonding is a special type of intermolecular forces present in the permanent polar molecules. This bonding can be considered ionic dipole-dipole attraction. This force of attraction dipole develops between molecules that have a hydrogen atom bonded to a small, highly electron private atom with the lone pair of electrons, such as nitrogen, oxygen, and fluorine. The covalent bond between hydrogen atom and other atom becomes polar enough to create a partial positive charge on hydrogen atom and a partial negative charge on the other atom. The small size and high partial positive charge on the hydrogen atom enables it to attract highly electronegativity and nitrogen, oxygen, or fluorine atom of the other molecule. So partial positively charged hydrogen atom of one molecule attracts and forms a bond with the partially negatively charged atom of the other molecule. The bonding is called hydrogen bonding. This force of attraction is represented by a dotted line between the molecules. Ratio below hydrogen bonding affect the physical properties of the molecule due to this bonding point of the compound are affected greatly. For example, boiling point of water. Boiling point of water 100 degree is higher than that alcohol 78 degree because of more and stronger hydrogen bonding in water. The important phenomenon of floating of ice over water is become of hydrogen bonding. The density of ice at 0 degree 0.917 G minus 3 is less than that of liquid water at 0 degree 1.00 G minus 8 is in the liquid state. Water molecules move randomly. However, when water freezes, the molecules arrange themselves in an order form that gives them open structure. This process expands the molecules that result in ice being less dense as compared to water. Nature of bonding and properties. Properties of the compounds depend upon the nature of bonding present in them. Let us discuss the efforts of nature of bonding on the properties of compound. Ionic compounds. Ionic compounds are made up of positively and negatively charged ions. Thus, they consist of ions and do not the molecules is positively and negatively charged ions are held together in a solid or crystal form with strong electrostatic attractive forces. The ordinary arrangement of an sodium plus and chlorine ions in a solid crystal of sodium chloride is shown. The ionic compounds have following properties. Ionic compounds are mostly crystalline solid. Ionic compound in solid state have negligible electrical conductance, but they are good conductor in solution and in the molten form. It is due to presence of free ions in them. Ionic compounds have high melting and boiling point. For example, sodium chloride has negative melting point 800 degree and a boiling point for 1300 degree. As ionic compounds are made up of positive and negative ions, there exists strong electrostatic forces of attraction between oppositely charged ions. So, a great amount of energy is required to break these forces. They dissolve easily in polar solvents like water. Water has high electric constant that weakness the attraction between ions. Covalent compounds. The covalent compounds are made up of molecules that are formed by mutual sharing of electrons between their atoms. Covalent bond is generally regarded as weaker than one, and a unique bond. Covalent bonds are made up of two or more nonmetals. Lower molecular masses. Covalent compounds are gases or low-bounding liquid contrary to its higher molecular masses. Covalent compounds are solid. Generally, properties shown by covalent compounds are as follows. They have usually low melting and boiling point. They are usually bad conductor of electricity. The compound having polar character in their bonding conductor of electricity when they dissolve in polar solvent. They are usually insoluble in water but are soluble in non-aqueous solvent like benzene, ether, alcohol, and acetone. Large molecules with three-dimensional bonding from polar crystal, which are very stable and hard. They have very high melting and boiling point. Polar and non-polar compounds are, as discussed earlier, the polarity in a chemical bond is due to difference in electron activities of the bonding atoms on the Pauling scale. Chlorine has been given an electronegativity value of 4.0. The values of for other elements are calculated relative to it. Properties of non-polar and polar covalent compound differ to the same extent. Non-polar covalent compound usually do not dissolve in water, while polar covalent compound usually dissolve in water. Similarly, non-polar compound do not conduct electricity, electricity, but an aqueous solution of a polar compound usually conducts electricity due to the formation of ions as a result of its reaction with water. Coordinate covalent compound. Their properties are mostly similarly to those of covalent compounds, as the nuclei in these compounds are held by shared pair of electrons. Therefore, they do not form ions in water due to their covalent nature. They form solution in organic solvent and are less soluble in water. Usually, they are rigid compound with the dipole metals. Metals have common property of conducting heat and electricity. It gives them prime role in many industries. Major properties shown by the metals are as follows. They show metallic cluster. They are usually malleable and ductile. Malleability is the property by virtue of which a metal can be rolled into sheets, while ductility is the property by virtue of which a metal can be drawn into wires. They have usually high melting and boiling point. Being greater in size, they have low ionization energy and form cations and very easily. They are good conductor of heat and electricity in solid and liquid state due to mobile electrons.